Let's study 10th standard ICSE Math, chapter 16, LOCI. We are going to skip 16A, easy sums, and 16B, the first 17 sums. They're all theory based, we just go through them. But let's start with sum number 18 onwards. Now we are going to do all the odd numbers, that is 19, 21, 23, 25, 27, 29, and 31, which are most likely to come in exam. And LOCI is basically the set of all points. Now remember a few terms here, which is after the exercise. Centroid is where all the medians meet. In center is where all the angle bisectors meet. Circumcenter is where all the perpendicular bisectors or the sides of a triangle meet, from where we can draw a circumcircle. More about it in chapter 19. Orthocenter is where all the altitudes meet. For an equilateral triangle, all these points will be one and the same. Now let's start with sum number 19. So first we draw a triangle. The midpoints are given for two sides, and then we have to draw the locus of points which are equidistant from BA and BC. Remember that the locus of something equidistant from two sides of a triangle is always the angle bisector. So this is a rough diagram. Let's always start with a rough diagram. 8 centimeters, 8 centimeters, 60 degrees. And the locus of the points equidistant from AB and BC will be this angle bisector. If they would have asked for the locus of points which is equidistant from point B and point C, that would be a perpendicular bisector of BC. Anyway, so BC, this angle bisector is Roman number 1. Roman number 2 is locus of all points 4 centimeters away from M. So away from M, this is the M, the midpoint of AB. So that locus would be basically the circle of radius 4 centimeters. Similarly, they want a locus of points 4 centimeters away from N. So that'll be another circle of 4 centimeters with N as the center. And then they've asked, mark the point P, which satisfies all these three conditions. So probably the point of intersection of the two circles and the angle bisectors is around here, which is called P. And then we have to join them, and they want us to identify the figure. So the figure will turn out to be a rhombus. When you will draw this and you'll measure all the sides will be equal, and when all sides are equal, it's a rhombus. But that is not visible in the rough diagram. For that, you have to actually draw it. Okay, what if they ask us to draw a locus of all points which are 4 centimeters away from AB? Well, for that, we should draw a parallel line which is 4 centimeters away from AB. But that is not asked in this sum. So step number 1, draw a triangle with the given details. So I'm going to take base as AC, which is of 8 centimeters. I'm using a pen, but you shouldn't. BC, 8 centimeters. Then I have to draw 60 degrees angle here. Remember, 60 degrees is an acute angle, not an obtuse angle. Obtuse angle would be 120 degrees. So I'm going to draw an arc. The rounder should not move and touch only one arm of the rounder. Don't touch the other arm. The 120 mark was not required. Anyway, so this is point. Always mark the points first and then join the points. Point. Perfection is required in constructions. A lot of patience is required. 60 degrees. And here again 8 centimeters. So that will be around here. That's point A. And then join AC. It's an equilateral triangle, of course. Now the angle bisector, so that is Roman number 1, which will be equidistant from the two arms. An arc is already drawn here, so I'll use that arm. From here, cut one arc, and from here also cut one arc. So that's the angle bisector, which will divide into 30 degrees each. Point of intersection is here. Be careful about that. Don't do it in a hurry, and don't fast forward this video. So this is the angle bisector, required angle bisector. So we have to name it as BX is the angle bisector, Roman number 1. Now Roman number 2 is this circle of 4 centimeters from point M. This is 8 centimeters and they want 4 centimeters, so it'll be around here, even here. 4 centimeters is out here. We can use a compass also to find the midpoint. So draw a circle. I usually like to rotate the book and not the rounder, but I don't have enough space to do that right now. Notice that the circle is passing through the vertices. Cool. So my measurements are not perfect because they should meet. The circle and the angle bisector should exactly meet at a point. So make sure you do it properly or cancel and redo it. I'm not redoing it. This is point P. In fact, it should lie on the side itself. Exactly on the side. So you cannot manipulate this way. This is wrong. Lose totally marks, all the marks. P. And then we'll join it. This is a rhombus. If you measure the sides, and yes, they can ask you to measure the sides and write it down. So write the answer. So Roman number 2, Roman number 3, and write rhombus. Don't forget to write that. Now the 21st sum. Now let's do sum number 21. construct triangle ABC, details are given. So this is a rough diagram. I'm taking AB as the base, then 75 degrees and AC is 4 centimeters. Then find a point P inside as well as outside the triangle such that it is equidistant from B and C. Whenever they say equidistant from B and C means what do we have to draw? A perpendicular bisector of BC, because every point will be equidistant from B and C, which can be proved by congruency of triangles. And the second condition is that it should be 1.2 centimeters away from BC. So that means I'll have to draw a line parallel to BC, which is 1.2 centimeters away from BC, both inside and outside the triangle. So that this is point P and this is also point P. Let's call it P1 and P2 because this will satisfy both the conditions. First of all, it is equidistant from B and C vertices as well as at a distance of 1.2 centimeters. Similarly, this is equidistant from B and C vertices as well as at a distance of 1.2 centimeters from BC. 1.2, 1.2. So always draw the rough work first, figure out the strategy to draw and then start drawing. So let's start. First of all, the base I'm taking is 4.8 centimeters. This is AB. AB 4.8. But they want 75 degrees angle. See, pen smudges a lot. That's why I don't use pen at all. You're not allowed. Draw an arc first. 75. So that'll be a bisector of 60 and 90. How to find 60 first of all? From here cut an arc. And from here cut an arc. The acute angle is 60 and the obtuse angle is 120. If I bisect them, I'll get 90. So let me do that also. You could have bisected 0 and 180 as well. So this is a 90 point, this is a 60 point. So let me bisect 60 and 90 to get 75 degrees. Now point, and then only draw. That's 75 degrees. And now AC is how much? It's 4 centimeters. Let's draw the triangle. BC. 4 centimeters. Now I've drawn a perpendicular bisector of BC, which is the locus of all points equidistant from B and C. So how do I do that? Perpendicular bisector? Well, from here outside the triangle, so that's not messy. Big arcs. Cut. Similarly, from here, cut and cut up and down. Now let's join these 2 points. This point and this point first. Make the points proper first of all. Perpendicular bisector. And now draw a line parallel to BC, both inwards and outwards. So for that, we always draw a perpendicular, which is already drawn, so that's good. Now 1.2 centimeters. So here and 1.2 here. Got 2 points. I'll draw a line parallel to this, passing through both the points. So again, that's a headache. 90 degrees. So cut an arc. Then from here, cut an arc. From here, cut an arc. Got the point of intersection, and then parallel line to BC. Similarly, from here, a perpendicular line. You can't just take a ruler and draw it doing guesswork. No, it has to be done with compass marks. There are marks for all these arcs made and following the correct method. Doing it freehand is very risky. So again, this one. Mark the point. Point. Did you get the point? So this is 1.2 and this is 1.2. So this is P1 and this is P2 as they wanted. So that's Roman number 1 and Roman number 2. Brilliant. Now the 23rd sum. Construct a triangle. Again, the details have been given. And find the points equidistant from AB and AC. That means the angle bisector. And also 2 centimeters from BC. And also measure the distance between the 2 points obtained. 23rd sum and 24th sum are very similar to the remaining sums, so cancel them. Let's jump to the 25th sum. Construct a triangle. Okay, let's do that first. So, in the triangle, base is 6 centimeters and the angle is 60 degrees. So now we know how to make 60 degrees. And then AB is 9 centimeters. So let's say here, AB is 9 centimeters. And then join this. Roman number 2. Construct the locus of all the points inside the triangle which are equidistant from point B and C. That means perpendicular bisector. So draw perpendicular bisector like this. Next, Roman 3. Construct the locus of the vertices of all the triangles with BC as the base and which will have area equal to that of triangle ABC. Now that means I have to draw a line parallel to BC passing through point A, because now if I take any point on this line, say here, and I pick a triangle with BC as the base, or take a point here and make a triangle with BC as the base, the area of all these triangles will be same. That's a property in similarity, that the areas of the triangles between the same two parallel lines and sharing the same base, that is having the same height, will always be equal. So that's the line they want. And now they want a point Q on this line such that it becomes an isosceles triangle. So definitely the point Q is this one, because Q is equidistant from B and C, since it's on the perpendicular bisector, and since its altitude is same as that of the original triangle, its area will be equal to that of triangle ABC, which is what they wanted. And finally they want us to measure the length of CQ. 0.1 difference is allowed. So now that we have the rough diagram, let's start drawing it. First we'll draw the triangle. Base is 6 centimeters. That's BC, 6 centimeters. Now they want angle ABC at 60 degrees. Oops. This is 60 degrees. Now AB is 9 centimeters. So now join A and C. That's a required triangle. That's Roman number 1. Now Roman number 2. Locus of all the points which are equidistant from B and C. That's the perpendicular bisector. I'm going to go far away. This is too far. My ruler will not reach those 2 points. Both sides, up and down. Up and down. Now I've got 2 points. Here's 1 point, and here's 1 point. Dot, dot, dash lines. Next. Oh, they've asked for the construction, so no dash lines, solid lines. Next, Roman 3. We have to draw a line parallel to BC passing through A. Now, how do we do that? Well, I have an idea. From point A, cut an arc here like this, and then from here, cut an arc, and from here, cut an arc. So now if I join these 2 points, I'll get the parallel line. So this is Roman number 3. You have to name them and write the names in the theory answer. So let's call this XY. So XY, this is triangle ABC, and then let's call this XA, line XA. Do this for all the sums. And now Roman number 4, they want point P. Okay, so I'm going to call this point P then. You have that foresight. Overriding is not allowed. Cancel and rewrite. Because now, if I join PB and BC, first of all, P is equidistant from points B and C, and the area of triangle BPC is equal to the area of triangle BAC, because they are between the same two parallel lines, the same altitude, that is, and they share the same base. So half into base into height will be the same answer. And finally, Roman number 5. By the way, this is point P. So Roman number 5, they want the measurement of CQ. Well, I noticed that in the question there is no P, it's Q actually. So this is Q. So they want to measure QC, and after measuring, you will get the answer around 8.5 centimeters. Next, cancel question 27 and 28. They are pretty easy, you can try it on your own. It's a part of the graph chapter. I will do 28 sum and then finally the 31st sum. 28 sum, read it. So it's a very easy sum. First we have to draw this isosceles triangle. I'm taking AB as the base 6 centimeters and AC and BC are 4 centimeters each. Then they want the angle bisector, and on the angle bisector of angle C, they want a point P which is 5 centimeters away from point C. So it's here. Now they want a point Q and R respectively, which is 5 centimeters away from P. So from away from P this much and this much, 5 centimeters, and also 5 centimeters away from A and from B. So let's start drawing. First of all, the base AB of 6 centimeters. Next, 4 centimeters other sides. We'll use a compass. Then they want the angle bisector of C. So from here, put an arc. Then from here, put an arc. Put an arc. The point. What do you want some background music in this video? This is the angle bisector. Now they want point B 5 centimeters away from C. That will be here. That's point B, 5 centimeters away. And now they want point Q and R 5 centimeters away from P as well as from A and B respectively. So 5 centimeters first of all is this much. So put an arc here and here. Then from A also. And then from B as well. So this is point Q. This is point R. No, actually they want 5 centimeters away from P and 5 centimeters away from line AB, not from A and B. So this is not right. Away from line AB, so I have to draw a line parallel to AB. So first of all, 5 centimeters away would be here. And now draw a line passing through this. For that, I'll draw an arc. So this Q and R is wrong. That's why I don't use pen. Extend the line. Now I got the parallel line. Don't draw parallel lines freehand. It's not allowed. You can't get it accurately. Not a superhuman. So this line is 5 centimeters away from AB. And it should be 5 centimeters away from P. So cut here and cut here. So this intersection is Q and R. You have the answer to join it? No. Now finally the 31st sum. First they want us to construct the triangle. Data is given. Then they want to construct a locus of points at a distance of 3.5 centimeters from A. That's a circle with radius 3.5 centimeters. Construct the locus of points equidistant from AC and BC. That means angle bisector. And rule number 4 is mark 2 points X and Y satisfying both the conditions, meaning the point of intersection. So the circle represents all the points which satisfy condition Roman number 2, and this angle bisector is a locus of all the points satisfying Roman number 3 conditions. So the point of intersection is this and this, so they are X and Y. So now let's draw it. First we'll draw the triangle. A base at 6.5. Now 60 degrees angle. AB is 5 centimeters. So that's Roman number 1. Triangle ABC. Roman number 2. Locus of points at a distance 3.5 centimeters from point A. That means a circle with radius 3.5 centimeters. Next, Roman number 3. Locus of points equidistant from AC and BC. That means angle bisector of angle C. from this point of intersection, draw an arc. From this point of intersection, draw an arc. They're meeting at this point, which is a coincidence, that it lies on the circumference of the circle. Angle bisector. Let's call it CX. So CX is the draw number 3. Draw number 4. Mark points X and Y. Sorry, let's call it Z then. CZ. Because this will be called X and this will be called Y. X comma Y. Because this point X is 3.5 centimeters away from A, as well as it is equidistant from AC and BC, since it lies on the angle bisector. And same thing is true for Y. Have they asked us to measure XY? Yes, they have, which is 5.2 centimeters. So you have to mention that XY is equal to 5.2 centimeters. Don't write so shabbily, write neatly. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.